Hey, it's Valerie, or Deanne if you go to my school. If you don't go to my school, you don't know that this is a chemistry project. Well, now you do. Welcome to the discovery of the atomic theory. So, this is my cover. Ain't it pretty? Hey, don't judge. And here's my table of contents. We'll start with Democritus, his discoveries, then go into Robert Millikan, Ernest Rutherford, J.J. Thomson, then there's John Dalton. After that, I will explain the atomic theory and the three basic laws tied to it. Then I'll go to talk about the atom, and I'll go to sleep when I'm done. So let's jump right to Democritus. He was born in a place I can't pronounce, and here's a picture of him. Yeah, I'm sure that's what he looked like after he met Medusa. Anyway, he lived to be in his 90s, yikes, and is considered the father of modern science. He had a theory that everything is made up of atoms and that they are indestructible. He also theorized that they are always moving. I theorize he is correct. Anyway, him and his partners, Lucy, we're going to call him L or Lee. I like Lee. And the guy I'm going to call Epi, they thought the solidness of a material had to do with the shape of its atoms. They thought iron atoms were firm. They thought water atoms were slippery and salt atoms were sharp. All of these are physical attributions. Oh, and here's another photo of them. I have no comment. Please make your own. You can even post them. I'm desperate. I know. All right, Robert Millikan is next. This is him. His area was the atomic charge. There was previous proof that atoms do have electric charges. We'll get into that later. There was no proof that subatomic particles existed, so yeah, they didn't know much. But Mr. Millikan decided to quantify the charge of an electron. This produced the oil drop experiment. Here it is. To me, it looks like a vintage espresso maker, but moving on. Through this experiment, Millikan discovered the charge of the electron. Now let's talk about Ernest Rutherford. I take it this isn't Ernest Goes to Camp? To cheer myself up from that disappointment, here's a pun. Chemistry is hard. It causes me all kinds of trouble. Back to not Ernest. This is him. This guy said the atom had a nucleus. I know. Insane, right? With the gold foil experiment, he found out that the mass of atoms varies. Impossible. That's French. Anyway, he shot alpha particles at the gold foil, and when he shot the ray, some of the particles reflected. That was unexpected. Hence, it proved that atoms have a nucleus and mass. Did you know that he could only see yellow? Here's an image. Wear safety goggles, people. Now on to J.J. Thomson. No comment? He first said, that atom is made of stuff. Oh, and this is him. He was actually the first person to say, that atom is made of stuff. He said, this is what an atom really looks like, and gave his people a watermelon. Technically, he gave them pudding, but I don't want to get distracted. Anyway, he talked about the bad stuff, but forgot all the protons, just like the news. Oh wait, they don't talk about protons. They forget the good stuff, though. Moving on, now let's talk about John Dalton and his mistakes. Mistake number 1, never moving. I mean, look at these photos. Did he ever change a pose? Anyway, he said 5 things, ever, and only 2 of them were wrong. He said everything is made of these things called atoms. That is true. He also said atoms of a given element are identical in size, ... and atoms of different elements differ in size, ... Wrong. I don't know how, but my teacher said it, so it must be true. Atoms cannot be subdivided, created, or destroyed. Also wrong. There's this thing called a proton, there's another thing called an electron, and one more called a neutron. They are what atoms can be subdivided into or from or something like that. He also said atoms of different elements combine in simple whole number ratios in chemical compounds. This is true. It basically means when you're simplifying a chemical equation that it stays in its simplest form, and that is true. He also said chemical reaction atoms are combined, separated, or rearranged. Yeah. Whenever a chemical reaction happens, stuff is changing. That's kind of what a chemical reaction is. You know, just a little. So, Now let's talk about the 3 fundamental laws of the atomic theory. And no, I don't mean the 3 laws that Newton came up with, as much as I wish that was that, because those are so easy. Anyway, one of the 3 fundamental laws is the law of multiple proportion, which basically is saying that when 2 elements combine in more than one proportion, the weight is just simplified. There's also the law of definite proportions, which means a compound will always remain the same in their mass. And finally, the law of conservation of mass. That means that mass can only be changed or transferred, not made from nowhere and not taken to nowhere. And now on to the atoms, my favorite part, the atoms of the atomic theory, the atomic of the atomic theory. So, we're going to start off by talking about the atomic number. The atomic number is the amount of protons that are in the atom. The amount of protons are very specific to an atom, or an element, rather. You can't have more than so many protons, otherwise you change the element in and of itself. It's also places where it goes on the periodic table, as you will no doubt see. They're all in numerical order, 1 to 117, I think. So yeah. Now to the atomic mass. The atomic mass is the amount of protons and neutrons combined. If you actually subtract the atomic mass by the atomic number, then you'll get the amount of neutrons. We'd actually round this up to 16, and 16 is 8 times 2, which you'll notice, because you kind of want to keep the amount of neutrons and protons and electrons as close as possible. That way you can keep them balanced. Yeah. Next, about the differences between these two. Well, just look at them. One of them is above the atomic symbol, and the other one is below the atomic symbol and the name. No, that's not the difference. The difference is the atomic number is the amount of protons, and the atomic mass is the protons and the neutrons combined. That's really the main difference. The atomic mass is most always going to be a decimal because it is very iffy. The amount of neutrons in an atom do have to kind of balance with the protons, like I said, because if you put 2 protons by each other, they repel each other like 2 positives of 2 magnets. If you push them together, they sort of push against each other. So they don't like each other. So the neutrons stay between them, so they try to keep as close as possible, but it doesn't always end up being like how we would like an even number. Sometimes it's like that, so we would round that up to 16. The structure of, well, the neutrons and the protons go in the nucleus together, and the electrons go in a shell on the outside of the atom. Yeah, there can only be 2 electrons, like you can have 2 there, and then you can have more than 2 in the next one. So, yeah. That's how it's kind of set up. The composition of the nucleus. And we've gone straight into biology because this is apparently a nucleus, and we are now talking about cells. No. The composition of the nucleus would be the protons and the neutrons in there. And most of the time they are in even numbers because, like I said, they have to buffer each other. They wouldn't actually look like that. They would be more like that. And I don't think the neutrons will repel each other. They shouldn't. It'll be like positive and negative canceling out, so it wouldn't exactly attract, but it shouldn't repel. And that is all I have for the structure of the atom for the moment. Now we're going to move into isotopes. Yay. Alright, last section. Yay! So here's a little meme, or pun, whichever you prefer, to brighten my mood because I am so tired, I'm ready to go to sleep. Okay, let's see. Define and give an example of an isotope. Well, this is an example of an isotope. It's helium 1, 2, and 3. And the do, of course, means 2, and the tri means 3. So the do has 2 neutrons when it should have 1, except it's an isotope, so it should have 2 actually. And the tri means 3, and it does have 3 neutrons. So a isotope really is just an atom with more neutrons than is the norm. There's a diagram, and I've identified it already. The element symbol is, of course, the element symbol. It's not always the first 2 letters, but it generally is. The atomic mass I've already explained, so have I already explained the atomic number? The atomic name, do you really need me to explain that? There's the bibliography, and that's it.